Good morning, students. In our last class, we have discussed two specific heat capacities. We have also justified the reason why gases have two specific heat capacity. And just to remind you, we have used small Cp and small Cv. One was specific heat capacity at constant pressure, another is the specific heat capacity at constant volume. Now, in continuation of this, today we are to discuss molar specific heats of a gas. Now, it was simple specific capacity. You can say ordinary specific capacity. Now we are to discuss the molar specific capacities of gas. Molar, right? Obviously, I just remind you, when we are discussing the ordinary specific capacity or just like the specific capacity, then we have mentioned it is the ordinary or normal specific capacity, means it is in that we are taking the amount quantity as 1 kg, unit mass of the gas, isn't it? Unit mass. But here we shall take 1 mole, molar specific capacity. In case of the molar specific capacity, you can write molar specific capacity at constant pressure. You write it is defined as molar specific capacity at constant pressure. It is defined as the amount of the heat gained or lost. It is defined as the amount of the heat gained or lost by 1 mole of a gas, by 1 mole of a gas, so that 1 mole of a gas, so that its temperature rises or falls by unity, so that its temperature rises or falls by unity at constant pressure. At constant pressure. You got the difference? In case of Cp, normal specific capacity, we have taken unit mass, means 1 kg. Here we have taken 1 mole. Similarly, molar specific capacity at constant volume, that is capital Cv, you can just make out the difference. These two C, here C is the small c. Here capital C. You have to make it very prominent that here the Cp and Cv in case of the molar are the capital letters. In capital letters they have it. That you have to be very specific about it. Okay. Molar specific capacity at constant volume, that is in the similar way, it is the amount of the heat gained or lost by 1 mole of a gas, so that its temperature rises or falls by unity at constant volume. Okay, and what is the relation? Capital Cp is equal to m into small cp. Capital Cp is equal to m into small cp. What is m? M is here the molecular mass. Here m is the molecular mass of the gas. Mass of one molecule. Okay, so it is the molecular mass of the gas. Obviously, capital Cp divided by capital Cv is equal to small cp divided by small cp. It should be equal to gamma, a constant. Okay, now there are different types of constant. On what this constant depends? Actually, this constant depends upon the atomicity of the gas. I just tell you, it depends upon the atomicity. Atomicity का मतलब क्या हुआ? Atomicity means whether the gas is monoatomic or diatomic or triatomic accordingly. For a monoatomic gas, it has some value. Suppose for monoatomic, I just give you the example. Monoatomic gases में gamma का value होता है 1.33, but in case of the diatomic gas में gamma का value होता है 1.4. It means I think you can very easily understand now. It is mainly depending upon the atomicity. It is not depending upon the gas to gas, just only the gases. It is depending upon the atomicity. जैसे हाइड्रोजन, ऑक्सीजन, नाइट्रोजन सभी डायटोमिक है, उन सबों का गामा सेम रहेगा. So this is the relation between the molar specific capacity and ordinary specific capacity. So this is all about the discussion regarding this molar specific heat capacities of a gas. With this, the specific heat capacities of the gas, and also we have seen that discussion is clear, and also we have seen why gases have two specific capacities, whether solid and liquids have only one specific capacity, that we have discussed. Okay, now after this, actually dear students, after this we have to move to our next topic. Our next topic is here. Let us now discuss the first law of thermodynamics. I want to discuss now the first law of thermodynamics. So let us now discuss the first law of thermodynamics. I think it is better we shall discuss it in the next lecture freshly.